Hello everyone. So in this video we will be solving a problem which is minimum absolute difference in BST. BST means binary search tree. So let's see the problem statement. Problem is saying that we have given a binary search tree having n is greater than 1 nodes. The task is to find the minimum absolute difference. Absolute difference is if the two numbers are 60 and 72. So 60 minus 70 or 70 minus 60. Both are giving me 10. Okay. So means we will get a positive number because of the absolute difference and between the any two nodes. Okay, so we have to find the minimum absolute difference between any two node. Okay, it can be left, right, it can be root node or left node, it can be root node or right node. So it can be any node. Okay, so let's see the example. We have given this example. So first condition I have to check, like here we have given that it is a BST, but the condition of BST is left node should be less than the root node, and the value of the right node should be greater than the root node. So this condition is following in this example, but let's see, we have to find the minimum absolute difference. So let's see this difference. So if we find the difference between these two, 50 minus 30, it will be 20. 30 minus 20, it will be 10. 70 minus 60, it will be 10. 70 minus 50, it will be 10. So minimum absolute difference that we are getting is 10. So there are two nodes whose absolute difference is smaller than 10. Okay, no node actually, sorry. They are no node. Okay. So minimum absolute difference is 10. You can see here, if you do the subtraction of any two node, then you will get 10, minimum 10. Okay. So if you do the 70 minus 50, also you will get 20, which is greater than the 10. But if you do the this 80 minus 70, you will get the 10. So it is a minimum one. Okay. So let's see this example. You will, if you do the subtraction of these nodes, like you will get 30. From this you will get 30. From this you will get 20. So 20 is the minimum one. So 20 is my answer. So let's see the approach for this. The approach part is very simple. See, we know that the in-order traversal in binary search tree, I'm talking about in binary search tree. Okay, the in-order traversal of a BST always gives me in sorted order. Okay, like if we find the in-order traversal, it is like L and R order. We have three traversal: in-order traversal, pre-order traversal, and post-order traversal. In-order traversal, what we do is we firstly print the left term, then node, then right term. This is the method of in-order traversal L and R. If we find the pre-order traversal, it will be NLR, or post-order traversal, it will be LRN. सो ये नोड का खेल है बस. जब इनऑर्डर ट्रैवर्सल होता है उसमें नोड बीच में आती है. LNR, दिस इज द ऑर्डर. सो फर्स्टली विल प्रिंट लेफ्ट. सो रूट के लेफ्ट में जाएंगे. लेफ्ट एग्जिस्ट करता है तो लेफ्ट में गया, इसके भी लेफ्ट में गया क्योंकि लेफ्ट एग्जिस्ट करता है. 20 प्रिंट कर दिया. ठीक है. फिर मैंने 30 प्रिंट कर दिया. फिर मैंने नोड प्रिंट कर दी 50. फिर मैं राइट में गया, फिर इसके भी राइट में देखा कि यार यहाँ पे राइट में गया, नोड मिली मेरे को. फिर मेरे को इन ऑर्डर रिवर्सल लगाना है तो लेफ्ट में गया, 60 मिला, फिर 70 मिला, फिर 80 मिला. So this is the array of in-order traversal. We know that and if we do the in-order traversal in binary search tree, it will be always in sorted order. So we are getting in sorted order of this array. So it will be like 20, 30, 50, 60, 70, 80. So now it is very simple to find the minimum term, because minimum difference, because we know that it is in sorted order. So it is obvious that first two term will be the difference of first two terms will give me the sorted, means minimum difference. Like if we do the difference, if we take the difference of these two, 30 minus 20, it will be 10. If we do the difference between 20 50, it will be 30. So we know that it is in sorted order. So first two terms का difference जो भी होगा वो मेरे को minimum बन देगा. तो it is obvious that if 30 minus 20 is 10. So this is my answer. So let's do the code for this. So coding part is very simple. Only just we have to write the in order case. So let's do the code for this. So for coding part में क्या करेंगे, फर्स्टली एक आंसर नाम का वेक्टर बनाएंगे. लाइक उसको मैं बोल देता हूँ एरे बोल देता हूँ. ठीक है, एरे बोल देता हूँ जिससे क्लियर रहेगी. एक एरे क्यों बोल रहा हूँ, जो इन ऑर्डर से मेरे को मिलेगा ना, इसको मैं एरे बोल रहा हूँ, ARR. नाउ व्हाट विल आई डू इज आई विल क्रिएट अ फंक्शन ऑफ इन ऑर्डर. In function I will pass root and answer. Okay. So let's create the function. So void in order. In function I will pass root node star, sorry, node star root comma vector int answer. Okay. Now I told you about this. First you have to write the base case for this. If root equals to null. It is not a base case, it is a condition actually, because we are not doing the recursive call, but it is like a condition. So if root equals to null, in that case I will return our our in order traversal जो भी array मिलेगा मेरे को. अब now मेरे को in order है, तो इसको मैं क्या लिख देता हूँ. फर्स्ट वी विल गो टू लेफ्ट, देन नोड को प्रिंट करेंगे, देन राइट को प्रिंट करेंगे. सो फर्स्टली वी विल गो टू नोड, सॉरी लेफ्ट. सो लेफ्ट में कैसे जाएंगे, इन ऑर्डर ऑफ रूट का लेफ्ट कॉमा आंसर. ठीक है. अरे आंसर नहीं है यार, ये यार एरे है ना मेरे को, ये आंसर लिख देता हूँ बराबर. ठीक है. ठीक है. लेफ्ट में चलेगा. अब मेरे को नोड पे जाना है, तो ए आर आर डॉट पुश बैक, क्योंकि नोड को प्रिंट करना है तो उसको वेक्टर में पुश करना पड़ेगा रूट के डेटा को. ठीक है. ये हो गया नोड का काम. अब मेरे को राइट में जाना है, तो राइट वाला भी सेम है. राइट में रूट के राइट में जाओ, कॉमा ए आर आर. ठीक है. This is the simple function of in order travel. So now what I'll do, now I have this array ARR which is in sorted order. Yeah, like you can see here. Now I have to find the minimum difference. So for the minimum difference, I will write like int mini equals to int max, because मेरे को तो minimum चाहिए ना. इनिशियली int max में शो करूंगा, और एक आंसर भी बना लूंगा int answer equals to जो कि उसके लाइक n बना लेता हूँ, n equals to ARR dot size. Now what I will do, I'll check a condition like I will apply a loop for int I equals to 0 to I less than n, then I plus plus. This is I am traversing the array. Now what I will do, like इसको बड़ा कर लेता हूँ. ठीक है. यहाँ पे फाइनली मैं रिटर्न भी करूँगा ना वैसे. हाँ, तो इसके बाद मैं रिटर्न भी कर दूंगा. ठीक है. उसका दिक्कत नहीं है, तो लिख देता हूँ मैं यहाँ पे. ठीक है. Now in function what I will do, I will check a condition like if we know that our first two numbers will give me the minimum one. Now how we will do this? Like should we like we will create a number. We are starting from one, because why we are starting from one? Because we know that the first number will be the which it will in sorted order. So first index will be greater than the zeroth index. So I'm starting from one, and now I'll what I'll do, int difference equals to difference of these two, like ARR of I minus ARR of I minus 1. And if we write the absolute difference, that will be okay. And if we will not write, then it's okay, क्योंकि एक sorted order में है. ठीक है. उससे फर्क नहीं पड़ेगा, बस सेम नंबर आ जाएंगे तो चेक करना पड़ेगा. ठीक है. एंड मेरे को क्या मिनिमम निकालना पड़ेगा, मिनिमम इक्वल्स टू मिनिमम ऑफ मिनी कॉमा difference. That will give me the minimum number. So after this loop, I'll return my mini, because that will be my answer, because I am changing the mini in each step. So let's compile and run this code. Yeah, it is working perfect as you can see. Let's submit this. Yeah, you can see here it is working perfect. All test cases have passed. So this was a simple code. In this code, what I have done is we know a condition that in binary search tree, if we find the in-order traversal, if we do the in-order traversal, the array that we will get from the in-order traversal, it will always be in sorted order. So we are using that condition, and we are creating a in-order traversal, this function in order function, and now we are getting the in array which is in sorted order. Now we are checking the minimum number, like it is in sorted order, so first two numbers, like it is not obvious that first two numbers will give me a minimum difference, but we can check that these numbers are smaller ones, so it can be like 50 and 55. So the difference between 55 minus 50, it can be a 5, which is a smaller one. So we have to traverse the whole array, but it is like first two numbers are smaller one, so first we have to check the from the first two numbers, then we will go again and again, so आगे जाते जाएंगे, ठीक है. Now we will go 50 minus 30, it will be 20, so 60 minus 50, it will be 10. If it is 65, 70 की जगह 65 होता, so 65 minus 60, which is 5. So 5 is the minimum one from till now. Till now 5 is the minimum one. So in that case I will return 5. But मेरे को 5 नहीं मिल रहा, 10 ही और मिल रहा है अभी तक. 30 माइनस 20 10, 50 माइनस 30 20, जो कि अभी 10 से बड़ा है, तो 10 ही रहेगा मिनिमम वन. 60 माइनस 50 10, 70 माइनस 50 60 10, देन 80 माइनस 70 10. सो अभी तक मेरे को 10 ही मिला है, तो 10 को मैं रिटर्न कर रहा हूँ. दैट्स व्हाई आई एम अप्लाइंग अ लूप फ्रॉम int i equals to 1 to I less than n, and I am finding out the difference between the two nodes. And where we are writing the AR of I minus AR of I minus 1, because we know that it is in sorted order, so AR of these elements can be equal, or AR of I is greater than AR of I minus 1, because it is in sorted order. So आगे वाला element तो हमेशा बड़ा होगा, ठीक है. And finally we are returning our answer. So this was the simple code. If you find this helpful, then please like, share and subscribe. तब तक के लिए bye.